time this afternoon to get started and see the webinar. So we'll get started here, and we will give you a brief introduction about SDA, Structural Design and Analysis Incorporated. We've been since 1977 providing on-site and off-site expert engineering analysis services for the structural and composites analysis for new and existing aircraft, spacecraft, and mechanical design. Our expertise and focus has been aerospace primary structures using composite materials, along with providing stress analysis for a variety of industries. Because of all of this, our project experience is pretty diverse. Many of the UAS and space industry products were developed with our expertise. SDA also offers engineering software and support. Our quality engineering analysis software that we represent was Femap, NX Nastran, HyperSizer, and Fibersim, which we'll be seeing the presentation and demo on that here in a few minutes. We also provide analyst-level technical support for all the above software products. We have an in-house staff of about 10 application engineer analysts. We also offer structural analysis services. We perform those services using Nastran, FEA, and HyperSizer optimization. Our finite element capabilities include statics, normal modes, buckling, nonlinear, material nonlinear, transient response nonlinear, and contact stresses. In addition to that, we offer some analysis services such as structure layout and design, some primary structure sizing, layup schedules, design review, material selection, manufacturing methods, strength testing, interpretation of results, failure investigations, and analysis reporting. Some of the projects we've been involved with are UAVs for their wing design, fuselage, control surfaces, and various structural components. Aviation components, structural enclosures, antennas, radomes, manufacturing engineering support, tooling design. Some of the other industries that we're involved with would be dredges, barges, submarine components, and ground support equipment. Now, with the webinar of composite analysis using Fibersim, Brady Walther is going to be presenting this to you. He's a 20-year industry expert in composites. He will give you guys a general introduction and overview how Fibersim is going to fit in the process of developing and managing the composite material systems. Brady will also give you a demo of Fibersim in the NX environment. He'll show some of the features on general application of an unmanned aerial vehicle system. Now, a little background on Brady. I'll let him continue, but he's personally used Fibersim for over 18 years. He's been directly involved in all the design and analysis of composite systems on a lot of the Air Force vehicles that you guys are familiar with, the F-35, F-22, F-2, and the X-33. Brady holds a master's degree in engineering mechanics from Virginia Tech, where he performed the fundamental research and development of the composite material system. So with that, I'm going to turn this over to Brady so that he, in turn, can get started with the presentation. And Brady, I've turned it over to you. You are now the presenter.
Okay, thanks, Marty. Appreciate that introduction. Like Marty said, I'm going to go through Fibersim. And one of the things that, before I get started, you know, Fibersim, Siemens has a wonderful brochure on Fibersim. It's about a 30-page brochure, and it's free. So I encourage you to email me, and I'll get you an electronic copy of that brochure. That way you can see some more aspects of Fibersim, and you'll also see a lot of what I'm going to do today in that brochure, and it'll just give you a chance to take a look at that. Okay, next. So what is Fibersim? So Fibersim really is a virtual production tool and it really is the management of the composite engineering. So it's the tool that we use for composite design, manufacturing, analysis, and configuration management. And it has some simulation capabilities also, and all of those allows us to really use the composite engineering environment to manage the composite definition. It's going to save a tremendous amount of money. On JSF down at Lockheed Martin in Fort Worth, we used Fibersim on that program from the get-go, and we encountered savings of close to 50% in our design and pre-manufacturing phases of that program, and I'll kind of tell you why. On F-22, what we experienced when we were making composite parts was we had an idealized part. We'd have our tooling made. That tooling would get manufactured. It would be very expensive, and then we would find out later on when we tried to actually build a part on that tool sometimes that we couldn't build the part. And that's the wrong time to learn that after you've invested in your tooling. The right time to learn that is in the design phase and really simulate it with Fibersim to kind of catch those type of things. So really it's going to keep the design, manufacturing, and analysis committees and the people that are doing this design, it's going to keep them all on the same page. It's going to manage the complexity of the composite parts. So we're going to get some interaction between the design and analysis house, design and manufacturing house, and then we're going to iterate with those. So we're going to have a lot of different layups. We're going to have a lot of different things that we're trying to do, and we need somewhere to keep that and store that so that we're all on the same page. And Fibersim does that. It really is a time savings and a money savings type of application. These are just some of the value. You can read those yourself. I'm not going to go over all of them, but I will point out on JSF aircraft, we were really a staple of Fibersim. It was really the first time Lockheed Martin had used Fibersim on a large program. And so we used it on the forward fuselage, we used it on the wing, we used it on the vertical tail, really all over the aircraft, but those are the pieces that I was involved with and that we used extensively. And we used it not only in the design phase and the analysis phase, but then also in the manufacturing and the pre-manufacturing of that. And we were really trying out Fibersim to show how it could save us money and gave us better quality parts. So a very integral part of the program, still is today. As a matter of fact, if you build a part for JSF from Lockheed Martin as a supplier, you will get Fibersim data. You will not get paper copies of the part. You will get Fibersim data, and you will have to read those Fibersim files. Okay, just kind of a general overview of what Fibersim does and kind of the general process here. Just kind of shows the flow. Fibersim lives in the CAD system. All the data is stored in the CAD system. So we're going to start, for example, in a CAD system, NX, a Siemens product. We never have to leave NX if we don't want to. Siemens has all the products that we need to do the complete composite design right in NX, and then the NX simulation modules, and then also in the Teamcenter modules. And basically what we're going to do is we're going to have a tool that represents, we're going to have a CAD that represents the tool, and in Fibersim we're going to be able to put features on there like cutouts, darting, splices. We're going to lay up like we lay up in the clean room. With that, then we can use that data to basically simulate the manufacturing producibility of the part, and then we can also export that out, or we can simulate it right in NX simulation. Basically, the structural analysis that comes from the as manufactured part, and we can check that out and make sure the analysis is good for the part. Once we've determined that the part is producible and that it is performance-wise, it'll meet the criteria structurally, then we can move and use Fibersim really in the manufacturing environment. So what we'll be able to do is we'll be able to give flat patterns and generate flat patterns out of Fibersim. And those flat patterns we'll then be able to put on a broad goods cutter. We'll cut those, and then we'll use a laser ply projection out of Fibersim that will allow our technicians to lay those parts up very accurately so we know exactly what we're going to get. So that's the general flow. So let's get into the demo. Here's the demo topics. I'm not going to cover everything. This is an introduction to Fibersim. I'm going to give you a pretty good cross-section of what the tool can do as it touches each of those aspects that I mentioned, from design, manufacturing, and analysis. I'm going to run Fibersim inside NX. I'm going to generate a general layup. I'm going to show you the producibility simulation. I'm also going to show you some corrections to that producibility. The next thing I'm going to show you is material directions out of the simulation as manufactured. Then I'm going to show you the flat pattern generation feature. And then we'll move into the documentation features of Fibersim with 3D cross-sectional sections and then also ply tables. So that'll give you a pretty good view of Fibersim, but there's a lot more to it. And I can follow up with you and give you more if you're interested. Okay, so let's look, I'm just going to give you a general slide here of what I'm going to do. I'm going to use a general UAV. And that UAV, I'm going to basically simulate this part right here, this forward fuselage part that's in orange. I'm going to use Fibersim. This is how it's going to be in NX. Fibersim is going to be running, and I'm going to basically use that as my tool surface to generate the parts. Everything will be stored in NX, and I'll show you that. Okay, so let's go over to the NX environment. As you can see, this is my aircraft, as I said. I'm going to turn that off just so that we can see the part better. And I'm going to flip this over as a true part. But this is that forward fuselage part that I was talking about. So that's going to be our tool, and that's the simulation that I'm going to run. So I'm going to fire up Fibersim. And in Fibersim, so this is the module in Fibersim. I'm still in NX. Fibersim runs on 3 platforms. It runs on NX, it runs on CATIA, and it runs on Pro-E. I'm going to run it in NX, NX9, and I'm going to run Fibersim 13.1. And basically, I am going to do a general part, a very simple part. And so the first thing I'm going to do is I'm going to give it a part name. So forward fuselage 001. I'm going to give it a material. Fibersim comes with a database of materials. It also can be added to, and so it's very easy to do that. But you can see the general database, basic database that comes with Fibersim. I'm just going to use a fabric. So this is a woven fabric, and it's basically a pre-preg that I'm going to use in my layup. And I am going to then look at the layup surface. So this is my tool, and we're going to lay this up with the composite build-ups, plies. And so those plies are going to drape in this tool. So basically we're going to then cure that part in the autoclave or out of autoclave, whatever you want to do. And this is going to be our tool surface to make that part. So I'm going to select my tool surface. I'm going to select my net boundary. And what I mean by the net boundary is this is the boundary that I'm going to trim the part to. So this is as it will go onto the aircraft, what it needs to be to go on that aircraft. And so that's going to be my net boundary or my trim to boundary. The next thing I'm going to do is I'm going to select my extended boundary, and that's the boundary that I'm actually going to lay up to. That gives me some material that I can, or room for some material that I can then trim to. Okay, so that is basically my composite part, my tool. I've made that now. Now I'm just going to go over here and I'm going to do a material direction. So I'm going to tell Fibersim these are my master material direction that I want to designate. And so what that means basically is this is going to be my 0 direction here on the tool. And then this is going to be my 90 and my 45. So anytime we have composite materials, we have a fiber dominated or a fiber direction. And so we're going to want to know what that fiber direction is or what we're going to assume it is. And so this 0 direction, that's basically what this does. It just shows that this is going to be a 0 direction on the tool or on the part, and then everything else will be measured accordingly. So that's created. Next, I'm going to create an actual ply. And I'm going to simulate that ply. So I'm going to run the producibility. So I'm just simulating what that first ply looks like on the tool and how well does it drape and conform to that tool. And so this is the first time that actually we can work with manufacturing here and say, hey, we've got a problem. We're not able to drape this correctly. It will have wrinkling, and Fibersim is indicated it will have maybe wrinkling here or bridging of the material, so it's not going to lay flat. It's kind of like wrapping a Christmas gift, and so it's not going to lay flat here. So Fibersim is telling us there's a problem with this producibility. So we already know that either we got to make some changes here, we got to do some different things, and there are some techniques to do that. So the next thing I'm going to do is I'm going to try to relieve that. So I'm going to use a technique. There's many techniques in Fibersim to do that. I can do splices, I can do darts, and I can do different kinds of darts. I'm going to just put a slit dart in this one to show the capability. So I'm going to put a slit dart into the material, and basically what that means is that I'm going to cut the material. So I'm going to relieve the material basically to allow it to lay flat. And so I've created that slit dart. It's here. I'm now going to link it to my ply. I have to create that ply again, sorry. I'm going to have to link that to my ply so that I do that on each ply. You can have as many slit darts as you want to make it producible. And you can see now that I've relieved that red bridging and whatnot. So Fibersim now is saying, hey, your material, this should work, this should lay correctly, and that's basically what that's saying. So then you could work the other areas of the part. You can do splices, whatever you want, to relieve that and make this tool work. The other thing is we want to let the analyst know this. So we're going to have to tell the analyst that, hey, there's going to be in order for us to manufacture this, there's going to be a cut through the fiber right here. And they're going to want to make sure they check their analysis and make sure that's not a critical area or that's a showstopper for them where the structural analysis will not pass. So this is a real good time to communicate that to them because we can move this dart appropriately and work with them at that level. Okay, the next thing is I'm going to just I'm going to create a flat pattern of this material so that you can see that. And I'm going to come back to that flat pattern real soon. But one of the things I want to do here is I want to also show you that these are all material directions. So as the material is conformed to the tool, the material direction is going to change off that 0 degree, and it's going to drift. And so with that, one of the key pieces of the Fibersim tool that I use quite a bit is exporting that out to an analysis package so that I get true material angles. And so what I'm going to do is I'm going to export this out, and I'm going to pick it up in another Siemens product called Femap, a very good finite element code that we use for composite analysis. It's running in Nastran. And basically what I have here is this is the part, the finite element part, the structural analysis part, as an idealized part on the top. So this is how I would set it up in Femap if I didn't know anything about how it would be manufactured or how it would drape. And you can see the material directions are just these arrows right here. And it's I use the axis, which is generally true what an analyst would do. I use the axes, the y-axis, as my general direction for the 0 degree, and this is as designed. So it's as idealized, basically. As this thing wrapped, it has no idea that as you wrap this, that those angles, those fiber angles, are going to change. So that's what I got from the export out of Fibersim. So this is that same ply out of Fibersim, and you can see where we had that other red down here. You can see actually where the material angle is drifting quite heavily. And so the analyst is going to be able to do an as manufactured type of simulation, not an as designed. You can only do that with Fibersim. And so now you're going to get a much more accurate simulation of the part as it truly is manufactured. And that'll allow us to correlate a little bit closer to the strain gauge surveys that we would do on this part to show that we had good correlation between our structural analysis and actual load data that came off the aircraft. And this only comes out of Fibersim. You can build these up and get the true material angle of the as manufactured. I'm going to go back to NX, and I'm going to go back to the flat patterns. So let's say everybody's happy with that, and so we're moving right along. I'm just going to move this over so you can see the flat pattern. But basically, you see that flat pattern over here, and it shows what that needs to look like to go over that part, and then it also shows you the slit dart. So there's that slit dart that I put in, and that's how that needs to be cut. The material comes in big rolls. It's flat, and so we got to cut it, and then we got to wrap it like a Christmas gift. So this is what Fibersim is projecting as the flat pattern to perfectly produce this part. Okay, so now we're going to go over to back to my presentation, and I'm going to show you how we use that in manufacturing. So this is a NASA type of part or structure that we actually did a flat pattern on. We used Fibersim to give those flat patterns. We then nest those flat patterns. That way we don't waste material. Those flat patterns are then put onto the broad goods cutter, and we cut those perfectly, exactly what they need to be. Then we kit those. We give those kits over to the technicians that are going to, the manufacturing guys that are going to lay this up. We also export out the laser projections, and those laser projections guarantee basically that we'll be able to place the plies and the core exactly where we want it. And this is really important, especially for the analysis, because we don't want material misaligned, and we don't want material in the wrong areas. We specifically want material exactly where we want it for the loads or the stiffness or whatever we want from the material response, and we don't want those misaligned. So this is a very important aspect of Fibersim, and it's the laser ply projection, and we used it quite heavily on JSF for complex layups to make sure that our buildups were correct, our core was located correctly. Okay. Next, I'm going to go back to NX, and I am going to go into the documentation pieces. So once again, there's my aircraft. I'm going to go back into the part. As you see on your screen, same part. I'm going to fire up Fibersim again. Bring it back into view. The only thing I've made this a little bit more complex. I've now got 8 plies of fabric on this part. The other thing that I've done just to add for this part of the demonstration is I've added core. So there's a piece of core that I've added right in this area that I've got highlighted, and that core is here. So we can do all kinds of different types of cores. We can locate them how we see fit. So the next thing I'm going to do is I'm going to go into the documentation area. So one of the powers of Fibersim is all this data is stored in the CAD system. When I hit save, it's all there. So when the analyst picks it up, he opens it up, he's got all the data, the latest configuration. The manufacturing guy, when they open it up, they have all the latest data. They're not working on the wrong thing. And so And then when the designer picks it up, he's working on the latest and greatest. But we want to communicate what those layups look like. And so Fibersim has great tools on communicating that. And so I'm just going to show you the cross-sectional area. So I'm going to ask Fibersim to give me the cross-sectional area of that piece right there and show me what that layup looks like. And so that layup looks basically with those 8 plies. There's the core that I told you about that is built up. And it shows you the layers as colors of the different pieces. I can reorient those layers, I can change them, and all that's updated automatically in the tool. So we can look around on the scope and see exactly how the different pieces of this part are manufactured as we're actually looking at the 3D data. And that's very powerful between the analysts, the manufacturing guys, and the designers. So that's a very important piece of Fibersim. The next thing I'm going to show you is a ply table. So what we used to have to do is we would make 2D drawings of all these parts, and then we put a manual table that would show what the ply schedule is, and that we would have to type in, and then we would, if we changed something, we'd have to go in there and retype it in, and there might be printouts out there, so we would get confused of what the layup was. We might fat finger something in that was incorrect. It got down on manufacturing floor with the print, and that's what was built. So we want to avoid that as much as possible. So the nice thing about Fibersim is, since all this information is in the CAD, then what we can do is we can make a ply table very quickly on the data that we have entered and show exactly what that ply schedule is, not only graphically with the the 3D pieces, the cross section, but then we can also make a ply layup table that shows you the 8 plies, the core. It shows you exactly what that material is, and then the orientations of that material. And so we can do that all around the part through the different pieces, and that is all updated automatically in Fibersim, and so that it reduces the amount of error. It also reduces the time. We used to spend a tremendous amount of time generating these ply tables, 90 plies. It would take a long time, and now we're able to just click and get that table really quick. So that's a really cool feature with Fibersim. Okay, so I'm going to go back to the presentation. Okay, so I'm going to go back to the presentation and just kind of show you what I've told you today. Just a little bit of a recap. I basically showed you Fibersim in and X. I showed you the general layup process. I showed you the producibility simulations of Fibersim. I showed you how to work for better producibilities through Dart selections. I also showed you the material direction simulation. Picked that up in the finite element package of Femap. And showed how the analysts would analyze that. I also showed you the flat pattern generation capability, and then also the 3D cross-sectional view capability in Fibersim, and then also the ply table generation in Fibersim. So with that, I appreciate your time, and I'll open up for questions. I also remind you that please email me for that free brochure. I'll be glad to send that to you. So I'll open it up for questions at this time.
Okay, Brady, while we're waiting for some questions, I just wanted to also thank you for your time with regards to the demo and presentation of Fibersim. It was excellent. For all our attendees, we will be recording this and putting it up on our website along with our new webinar series. So we invite you guys to come back, look around our website, see if there's any additional information you may need. If so, feel free to email us. Drop us a line at any time. If you have some questions about a specific composite project you're working on or analysis project, again, feel free to give us a call, and we look forward to working with you guys and helping out any way that we can. So with that, thank you all again for attending the webinar on Introduction to Composites with Fibersim from SDA Inc. If anyone does have a question, they can raise your hand on your GoToWebinar area there, and we can answer any questions you may have at this point in time.
Hey, this is Jeff Ickham with Textron Systems. I wanted to ask Brady if it's possible to exaggerate the cross-sectional thickness of a ply stack-up for illustrations in assembly documentation.
Yeah, hey Jeff. Yeah, absolutely. And one of the features that I'll need to show you at some other point in time is I can actually generate 3D solids from that. So Fibersim has a way of generating the 3D solids from those cross sections, so then we can actually get a true 3D representation solid in NX for any kind of interferences as we move through the design. So,
okay.
Yeah, and you can have as many cross sections as you want, Jeff. So I can make cross-sectional views and show those throughout the part.
And if you do a simple slit dart and overlap, I guess in your case you spread the material, or I guess in some cases you'll overlap. Do the 3D cross sections automatically account for the growth locally where you have the overlap, and then is the solid reflect that local doubling as well?
Yeah, so if I had any kind of doubling there, now Fibersim is going to assume that that slit dart is going to come back together perfectly.
Like a perfect point.
Yeah, it's going to assume that it comes back perfectly. It's not going to overlap that dart. So I'd have to do that in Fibersim, and there is a way of doing that to make it actually reflect that correctly if I felt like it was going to come together with a low overlap.
Right, like you sort of mentioned, I guess there's a lot of options for how to deal with gapping and all that sort of thing.
Right, and I'm just showing you some introductory pieces here. And when we get into the details of those parts, there's a lot more power to Fibersim that we make it even more accurate so that we really truly get what we're trying to manufacture.
Okay, Brady, I don't see any other hands raised, so I believe that we're going to be finishing up here. Again, anyone that's left on the line, if you do have any questions, feel free to email us or give us a call down the road here a little bit. Go out to our website and peruse through that, and there's a place where you can send us an inquiry about any questions you may have regarding the composite Fibersim or any of our other products or services. Thank you very much.
Thank you.